Today we're going to look at section 5.3. It's all about proving triangles are congruent by ASA and AAS. What do you think ASA stands for? Angle, side, angle. And the other one is angle, angle, side. They sound alike. They are very much alike, but they're not the exact same thing. Okay? So we're going to have to talk about why they're different. All right, whenever you're ready to listen, I'll start telling you. Right. Okay, so it all matters if the side is included or not included. Okay? So if you have two sides, if you have two angles and the side in between the two angles, that's called the included side. That's when it would be angle, side, angle. When the side is not between the angles, then it's angle, angle, side. So in both of these scenarios, we'll have two triangles. We'll have two angles and a side from one that match or correspond with two angles and a side from the other one. And we have to decide which one it is. Is it the side in the middle, angle, side, angle, or is the side not included? Then it'd be angle, angle, side. Now, you still will see the ones from Friday pop up as well. So side, 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 and side, angle, side. Remember we talked about there's going to be 5 total ways to prove that triangles are congruent. So 2 from Friday, 2 new ones from today, and then we'll learn a 5th way before the end of the chapter. Any questions so far? All right, here is number 1 through 4. The directions say tell whether the side is included or not included between the given angles. So AB is blank between angle A and angle B. So it is in between those two angles or it's not in between those two angles. So here's angle A, here's angle B. Is side AB between the angles? It is, so you'd say included.
On the line?
On the line you would write the word included. Yes? Sure.
Yeah.
All right, the next one, same angle, so angle B and angle A.
Not included.
Is BC between them? No, so that would be not included. And if you're struggling, grab the highlighters, grab the crayons, grab the markers. There's lots of supplies in here. And look where the angles are. You can actually trace the angles. Angle A, angle B, and then BC is over here, not in between the two angles. All right, the next one. CA. Is CA included or not included between angle A and angle B? So CA is over here. Is this side between angle A and angle B?
No.
It is not included.
No, not included.
And then the last one is also not included. You are correct, because CB is not between angle A and angle B. Kind of the same question as number 2, right? All right. Questions on 1 through 4. Anyone need more time? All right. Here is the actual postulate we're going to be working with today. The angle, side, angle postulate. It says that two angles and the included side of one triangle are going to be congruent to two angles and the included side of a second triangle, and then you can include that the two triangles are congruent. So here's a good diagram of what this is going to look like. So it has to be the included side. So you have an angle, then this side, then another angle, and it matches up, it's congruent to an angle and then a side and then another angle. So go ahead and label those triangles in your notes. So here is that diagram described. So we have angles. Angle A is congruent to angle D. Side, segment AC is congruent to segment DF. And then angles again. So angle C is congruent to angle F. Then you can conclude that triangle ABC is congruent to triangle DEF. Number 5 says, does the diagram give enough information to use angle side angle congruence postulate?
No. Yes,
No, what would this one be?
Side angle. Side angle.
You're close, but there's no bad words in geometry.
Oh.
Side, angle, side. Good. So no, need the two angles for angle, side, angle. Or you could say no, this would be side, angle, side. Either reason works. So we don't have enough angles. We need two angles. But it does work on side, angle, side. Questions? All right, number 6, same question. Does angle side angle work?
Yes.
No.
No.
That's 8. Oh, angle side.
What if I add that mark? Does that change your answer? Yeah, remember if it's the same segment in both triangles, you can mark it as being congruent to itself. Now we have angle, side, angle. So this would be a yes. It's the two angles and the included side. Questions? All right, the next one, it's very similar, like I said, but it's now the side that's not included. So if you have two angles and the non-included side of one triangle, congruent to two angles and the corresponding non-included side of the second triangle, then the two triangles are congruent. So here's what it would look like in a diagram. So if you trace each triangle separately, you have angle, then an angle, then a side, angle, angle, then a side. And there is it described. So angle A is congruent to angle D. Then as you're tracing the triangles, you run into an angle again. Angle C is congruent to angle F. And then you go to the sides. And that is enough information to conclude that these triangles are congruent. Example 7 says, does the diagram give enough information to use angle, angle, side? So we want two angles that are next to each other and then the side, not included between the two angles. Yeah. Is that what we're looking at here? No. What is this?
Angle side.
ASS. Is there such a thing as the ASS? Yeah. So you would just say no, and then you could say that there is no ASS postulate, or you could say don't say there's no bad words. That's just my memory trick. So
If you spell it out, you say it. What can you say?
you could write there is no angle side side, or you could put ASS. Leave it all capital so it looks like the rest of them. But no, I would not take off if your reason was there is no ASS. It's right. I mean, it's actually, yes, it's legitimate to write. Probably the only time you can write it on a homework assignment. Or you can just describe why AAS doesn't work. So you need two congruent angles. And this one gives you two congruent sides. I'm glad you guys are so amused. Any questions? Geometry is so fun. Okay, hold on. Before you write anything, looking at this diagram right now, I see one angle matching with another angle and then one side. But what do we also have?
The middle, the point. The middle.
The middle point. What do you mean?
That point right there. The line ain't gonna do it. That point right there.
What does the point give us?
Congruency, like an X.
Yeah.
It's like it is.
Do we know anything about these angles?
They congruent.
They're congruent. Do you remember what those are called?
Congruent angles.
It starts with a V. You were close.
Vertical.
Vertical. So, don't forget all the ways to prove angles congruent that you've learned previously, okay? If you have vertical angles, you can mark those as being congruent. That's something we already know how to show, okay? Now, what do you have?
Angle.
Yeah, you have AAS now. So this is saying if I want to use angle, side, and I'm given this information right now, what do I still need? Now I heard someone say a side. What do we know about this?
It's split in half.
Yeah. So you already know that side is congruent because it's the same segment in both. So don't list that as what's missing. It's not missing. You already know it. It's just not labeled. What's missing? An angle. Which angles in particular?
DT.
C.
So hold on. If we had the angles down here around, hold on. Shh. If we had the angles down here, that would give us angle, side angle.
Okay.
Or if you went the other way, it'd still be angle, side angle. So would that work here?
T.
No.
No. So you need the other guys. We need angle E to be congruent to angle T to show that these two triangles are congruent by AAS. So now I want to use the other one, angle, side angle. So I have angle, side. What do I still need?
Angle.
Which angles?
S and M.
Yeah, angle M needs to be congruent to angle S. Whoa, no it's not. Who said that? I'm sorry. That would give us angle. Is there such a thing as angle? There is no angle. I don't know why. No, I was just taking your word for it. Shh. Now, if you have, I'll explain it. If you have congruent triangles, all the angles are going to be congruent. But it doesn't prove that the triangles are congruent by angle. So whoever said angle, you said it so convincingly, I went for it. But we're totally missing the side. So we need the side between the angles. Could I have used these sides? Could I have used a different pair of sides? Like ML and ST, would that have worked? No. That would have been angle, side. We want angle, side, angle. All right, questions? Sorry, I got a little too trusting in you guys there for a second. All right, number 11. I'll pay closer attention this time. All right, so we have two triangles. We want to use angle, side, angle. Now, someone said side. Do we know anything about this? They're congruent. We already know that from the diagram. So that's not the one we want to list. The one we want to list is what? The angle, and it has to be the angle that would make the side included. Hold on. If we did angle V and angle I, we'd have angle, side. Is that what they want us to use? Getting a little noisy, guys. They want angle, side, angle. So angle, side. So we need this guy and this guy. Can I use the one-letter approach? I could say angle H and you'd know what I was talking about. No, there are three angles with the vertex of H. There are three angles with the vertex of G. So we need to use the three-letter, okay? So here's one option, VHG and IGH. Remember, you could go the other way, but you'd have to go the other way for both. So you could do HGI and then GHV if you wanted. Questions? All right, so on number 12, we want to use angle, angle, side. Right now we have angle, angle. Angle, angle, so what's missing? The side. Now, in this one, you do have some options. Just make sure it's not the included side. So do not do YX and ML. Those are the two you can't do. So what's one pair of sides that would work?
N and Z.
Hold on, ZX would have to go with which one? ZX would have to go with.
It's CY.
You could do ZY, but right now I'm talking about ZX. If you wanted to do ZX, you'd have to go to which one?
Oh, wait.
NL. If you start at the one not labeled and go to the one labeled with 2, you'd have to go to the one not labeled to 2. Or if you want to use ZY, you'd have to do what? NM. Good. All right, so here are both options. Again, we had 2 options here because there are 2 sides that are not included between the angles we were given. So pick either one and its partner. Okay, so these 2 match, these 2 match. You can't mix and match though. You can't do like ZY and NL or something crazy like that. You got to pick the 2 that actually correspond. Questions? All right, number 13. So now we're putting all 4 of them together. We're saying decide whether enough information is given to show that the triangles are congruent. If so, tell which congruent postulate, the 4 we've learned, that you would use. So can I show these triangles are congruent and how?
Yes.
No.
Yes.
All right, you say yes, why?
Because you put them on top of each other.
That's not a reason that we've learned. Anyone else have some thoughts?
They all located in the same place.
I know 8 is. Wait, what?
Yes, it is.
Wait.
What
was your question?
Can I show these are congruent using one of the 4 postulates we've learned Friday or today?
Yes.
Now there's a point in the middle, which is the center point.
Okay, a point in the middle doesn't mean anything to me. What are these called? Vertical angles. Use the correct terminology.
They intersect.
Those are vertical angles, so they're congruent. Now, could we use one of those?
Yes.
Which one? Right.
I was right.
Yeah, angle, angle, side, angle, angle, side. Now, shh. Do not write side, angle, angle. I see it every year. I mark it wrong every year. We don't call it side, angle, angle. So if you are tracing the triangles and you start in the wrong spot and you see side, angle, angle, just switch it and write it the right way, okay? Final example of today. Is there enough information to show that these triangles are congruent? Yes. And which one would you use? Yeah, I think this one's the easiest. Side, side, side. All 3 sides of one, go with all 3 sides of the other. Okay. So, this is the end of the first half of this chapter. So you can see we are reviewing tomorrow. We are quizzing on Wednesday, and we're going to get a test in before Thanksgiving. Okay? So we are moving quick in the next couple weeks.